Alrighty, my friends, let's take a look. Without using a calculator, sketch each function. Okay, let's see. X squared plus 4x plus 3. I'm going to factor that. So I got x squared plus 4x plus 3. So I need things that multiply to 3 and add to 4. So that's going to be x squared multiply to 3 and add to 4. 3 and 1 will do. And then that's going to be x plus 3, 1x plus 3. So I can rewrite that as x plus 1, x plus 3 on the bottom. So your vertical asymptotes are where the bottom is 0, so that's going to be x equals negative 1 and x equals negative 3. The horizontal asymptote is going to be y equals 0, because as x gets huge, the bottom gets bigger and bigger and bigger, and the top stays as a number. So that is 0. The y-intercept, we plug in 0, so that's going to be 0 plus 1 is 1, 0 plus 3 is 3, so that's going to be 5 thirds, 0 comma 5 thirds. The domain is going to be everything except for negative 1 and negative 3. And then the range is going to be the same thing as before when we talked about these previously. Y cannot be 0. Oh, actually, I think y is going to be 0. I take that back. I lied. Okay. If you wanted to graph, I find it useful to graph x plus 1, x plus 3, that curve. So that curve is going to look like this. The reason I find that useful is because I can draw in your vertical asymptotes. I'm going to have a vertical asymptote at negative 3. I'm going to have a vertical asymptote at negative 1. See how I have negative? I have positive and then negative and then positive. So when I do the graph, we're going to have positive and then negative and then positive. Helps me figure out what the graph looks like. Ooh, I was right on the range. Y cannot be 0. All right, sweet. Next one. We've got 2 over x plus 5. So x plus 5 is 0 at negative 5. So x equals negative 5 is a vertical asymptote. As x gets huge, this part goes to 0, but then we subtract 4. So the horizontal asymptote for this one is going to be at negative 4. Y equals negative 4. The y-intercept, we plug in 0 for x. 0 plus 5 is 5. So that's going to be 2 fifths minus 4. Let's put that in terms of fifths. So that's going to be 20 fifths. So negative 18 fifths would be the y-intercept. Negative 18 over 5. And if we had x plus 5, if we were to graph that, and then minus 4, that'll give us an idea. So x plus 5, I'll do this. X plus 5 is going to look something like this, a line where you have negative stuff and then positive stuff. So that's going to tell me where my swoopies go. So my swoopie is going to be negative stuff and then positive stuff. Didn't ask me for an x-intercept. I could have found an x-intercept also. All right, next one. Write a rational function of the table provided. Explain your reasoning. We don't exist at negative 2. So my first thought is going to be, let's put an x plus 2 on the bottom, and let's try putting a 1 on top. So when I plug in 0, I need to get 1. When I plug in 0, I get a half, all right? So I don't want a half. I want 1. So when I plug in 0, I get 2 over 0 plus 2, which is 1. When I plug in 1, I get negative 1. Negative 1 plus 2, which is 2 over 1, which is 2. When I plug in 3, negative 3 plus 2, that's going to be 2 over negative 1, which is negative 2. And when I plug in 4, 2 over negative 4 plus 2 is 2 over negative 2, which is negative 1. I matched all the points. So I started with the vertical asymptote, and then I played with the y-intercept because that was an easy one to plug in, but I played with any one of the points to figure out that I needed a 2 there. Another way I guess you could conceptualize this is if you wrote it as a over x plus 2, and then when you equals y, and then when you plug in, suppose you plug in 0 for x and 1 for y. If you solve that for a, you'll get 2. So 2 over x plus 2 is going to be my equation. Write a rational function for the description. Let's see. Domain is all real numbers except -7. Okay, so that means -7 is a 0. A graph contains the point -3, 1. All right, so I'm gonna do that strategy I just said. Suppose that that's my function. So let's plug in 1 for y and -3 for x. -3 plus 7 is 4, so multiply both sides by 4. That means a is 4. Get rid of that. Put a 4 there. I still have my range is all real numbers except for 0. That's because I have that horizontal asymptote thing going on. I don't have a shift or anything like that. And then domain is all real numbers except -7 because I eliminated that from my domain. So that is one possible choice. I suppose there are probably others. All right, rational expressions. So perform the indicated operation. I'm going to do this. I don't know if it's the best move. And I'm going to factor that. So I have x squared plus 2x minus 24. So I need things that multiply to -24 and add to 2. So multiply to -24 and add to 2. I think I chose wisely. Factor x plus 6, -4. So that's going to be x minus 4 and x plus 6 is factored that top piece. Let me get rid of this stuff. And then I'm going to write the pieces on the bottom. And actually, I'm going to do something devious. I'm going to move those pieces. And if they match up with things, I'm going to put what they match up with. So x minus 4, I'm going to put that here. X plus 6, I'm going to put that here. 2x cubed, I'm going to put that over here. And now I'm going to reduce to 1 everything that I can get rid of. So this is 1, this is 1, this is 1, and this is 1. So what I'm left with is I'm left with x minus 6 on the top and then 2x on the bottom. For number 2, I would like to get rid of that fraction to begin with. So I'm going to multiply both sides, whole thing, by x. So that's going to get me x squared, 4x over x, which is just 4, equals -5x. I'm then going to add that 5x to both sides because I'm going to hope I can factor. And to factor this, I need things that multiply to 4 and add to 5. So that's going to be 4 and 1. Then I'm going to do the greatest common factor. And I'm going to wind up with x plus 4 and x plus 1. This is equal to 0. So I should write the equations x plus 4 equals 0. That's going to solve x is -4. X plus 1 is 0, so that's going to solve as -1. And those are your answers.